We have already explained that the Moon's orbit around the Earth is driven by the Earth's rotating gravitational field. In the absence of external forces, the Moon's orbit is circular, and this is its basic orbit. To understand the actual orbit of the Moon, we must first know its basic orbit and the speed at which it rotates in that orbit. We know that the Moon has an orbital period t, and the orbital velocity of a body driven by a central body is as follows. And the period and velocity are related as follows. From these two equations, we can derive the radius of the basic orbit and the basic orbital velocity. Under these conditions, we can further examine the actual lunar orbit. Due to interference with the Sun's gravitational field, the Moon deviates from its basic orbit. This causes its orbit to oscillate back and forth in relation to its basic orbit. This orbit is obviously not an ellipse, as is commonly believed. Our calculations have shown that the so-called major axis of the Moon's orbit is sometimes slightly larger and sometimes even slightly smaller than the diameter of the basic orbit, depending on its position. If we had cut off the basic orbit and stretched it into a straight line, it would have looked like the one shown here. According to oscillation theory, the curve of the oscillation is a sine curve. Therefore, the lunar orbit curve can also be approximated using the oscillation formula. And the Moon's orbit can also be described in simplified terms. This lunar orbit is not only simple, but also very intuitive. It can be assumed to be more precise than the Kepler's orbit.